Okay, two questions. What's your question? Mm-hmm. Yep, yep. And what was your, what did you say? Yes. Yep. All right. So if they do you have one of those pulled up, or do you just want me to choose some numbers? Yeah. Give me your numbers that they give you. 4, 6, and 8. All right. All right. So they give you these numbers and they say classify this thing as obtuse, acute, or right. Correct? I'm gonna write down the relationship here. If c squared is equal to a squared plus b squared, what is that going to create? What kind of triangle if we meet that condition? That's going to be a right triangle. Okay. If c squared is smaller than a squared plus b squared, and this is the reason we talked about this. This is why I like to put c first in my comparisons. If c squared is smaller, what kind of angle is smaller than a right angle? An acute. So that would lead me to those things making an acute triangle. Okay. If c squared is greater than a squared plus b squared, then that would lead me to an obtuse. Does that make sense? Okay. Now, because of symmetry with regards to inequalities, you could, and some textbooks will show us, I think our textbooks, even if you do help me solve this, I think does something like this. They write or explain it as a squared plus b squared. If I want to write the same exact statement here, then my inequality needs to open towards a squared plus b squared, right? It's greater than c squared. This would be a squared plus b squared equals c squared. And this would be a squared plus b squared to keep the inequality. This is pointing towards a squared plus b squared, so it would have to be pointing there. Okay? I know this is going to be a right angle right there because the equality. When I read this one, because I read it left to right, I read greater than. A lot of people, if we're writing it in this red format, a lot of people will mess this up and say, well, it says greater than, so it's got to be obtuse. Does that make sense? But this statement here says the same thing as that one does, so this has to be acute. And this has to be the obtuse one. Even though when I read it with the A and B coming first, it says greater than. That's why I prefer to put c squared initially. So all you're going to do then is you're going to take, understanding that if this is going to make a right triangle, if this was going to be a right triangle, which one of those would have to be C? 8. Okay? Because C is the hypotenuse, right? And the hypotenuse is, by definition, the largest side provided. So I'm going to go 8 squared. And then we're going to ask, let's put a box here. Okay? Whether I put an equal sign, less than, or greater than sign there is going to be my decision. And then a squared would be 4 squared, and b squared would be 6 squared. So we get 64. Is that greater than, less than, or equal to 16 plus 36? So 64, how is 64 compared to, what's this going to be, 40, 52? 64 is bigger, right? So because 64 is bigger, I used a greater than sign. It's this relationship right here. So that must be, the only way that I can create that is if I use, it's got to be an obtuse triangle. That kind of makes sense? Okay. I'm always a person that I don't want to memorize a bunch of stuff because these are very similar, especially the first one and last one. But I don't want to memorize them. So I try to, because I'm going to transpose them or get them backwards every once in a while. So I try to develop a system that allows me to remember it or regenerate it a little bit easier than my memory. So that's how I would do that one. Any other questions? Say it again. 13. assign something to you. Aha, that's a good question. This is a great question. This is the questions you will see on your test. Does that look like something familiar to us? We've been dealing with that triangle for a while. Who would agree that we've been dealing with that triangle for a while? Who would disagree? Because this is not a right angle. Or let me rephrase that. We don't know whether that's a right angle. Okay? So if that was, let's talk about, this is chapter 7. If that's a right angle, then we've got geometric means, right? Because the corollaries in chapter 7 said, if an altitude is drawn from the right angle perpendicular to the hypotenuse, then you could say, 7 radical 5 is the geometric mean between 29 and 7. And that let you solve for, or you would realize that relationship. Or you could say X is the geometric mean between 29 and 22. That's if this thing here was indeed a right angle. But we don't know whether it is or not. Okay? They don't tell us that. So the only way that I can solve for X here is to realize what kind of triangle is that right there. That is a right triangle. Okay? And if that is a right triangle, can you find that distance right there? Can you find Y? Now, this is where students get kind of hung up on things because, well, it doesn't ask you to find Y. You're absolutely true, or right, it doesn't. But you need to find that distance so that you can move over to find X. Okay? So there's not going to be the instructions that say, and never a problem, find this intermediate value, this intermediate distance, so that you can migrate to finding X, the distance that we're interested in. Okay? It's kind of a puzzle or game that we have to play based on the things that we know. What else can we find? And then see, does that lead me to what I'm looking for? So it's kind of like if you ever played, you just see those people. Yeah, anybody ever been to like an escape room or something like that? Okay, where you're finding clues to get you to the next clue, to get you to the next clue, to get you out of that room, right? So the only way we get out of this room essentially is we find X. So we're going to try to look through this thing and find clues that are going to allow me to get to there. Okay? So this first clue is look at this right triangle here in green. And you've got 2 of the 3 sides, right? Would you guys agree that 7 squared plus Y squared, those would be the legs of this right triangle, correct? Should that equal 7 radical 5 squared? Okay. Now 7 radical 5, that is a singular value. Okay. But it's a product of 2 things. Okay. So it's you guys remember like A times B. Okay. If I had AB squared, then the way I rewrite the AB squared means AB times AB, doesn't it? Doesn't that mean A times A and B times B? Can I write it that way? Can I rewrite that then as A squared, B squared? So when I have this rule here of A times B squared, I can essentially distribute that A, or that 2, to the power of A and to the power of B. So I get A squared, B squared. The reason I talk about that, and it's really this, it's the exponent law that you learned last year, is something like A to the M, B to the N, raised to the S. We can rewrite that as A to the MS, B to the NS. We just multiply that by those 2 things. Does that make sense? And the reason I talk about that is because that's what we have to do right here. Okay? I have to square the 7. So it's 7 squared. And I have to square the radical 5. Well, what's 7 squared? 49. What's radical 5 squared? That's 5, right? Okay. What's 50 times 5? 250. So this would be 1 less 5, right? So shouldn't this be 245? That make sense? 7 squared is 49 plus y squared. Okay, can I solve for y squared? This would be, what, 196? Is that okay with everybody? If y squared is 196, does anybody know what the square root of 196 is? 14. So now that's the first clue. You know y is 14. Does that now give you 2 distances in this triangle to solve for x? So now we can go 14 squared plus 22 squared should equal x squared. 14 squared again is 196. 22 squared, is that 484? 44 equals x squared. So I'm going to, when I look at this, I see 190 plus 490. Does that make sense? Move that 6 over here and make that an even 490. So that'd be 590. So it'd be 680, right? Okay, so 680 is equal to x squared. Square root both sides. X equals the square root of 680. Okay. 680 is 68 and 10. 68 is 34 and 2. 34 is 17 and 2. 10 is 2 and 5. Would you agree that there's one group of 2's? And then the 17, the 2 and the 5, they go back together as 170. So 2 radical 170 is what we're looking for as that distance. Does that make sense? Okay, a lot of radical work there. And my hope is that if that's the thing that's going to provide us issues, is that you don't say, okay, I get the geometry, but I don't get the radicals because, and I'm not going to do anything on my own to alleviate my radical issues. That's going to be a big problem for you, because how do I judge, and this is any geometry class, how do we judge whether you know what you're doing? It's based off these algebraic answers, right? So we got to have the ability to work with radicals. Now, I want to do this. If that's 2 radical 170, I'm just going to write radical 680. It might make it a little bit easier here. Let's determine if this was a right angle or not. Okay, if that was a right angle, wouldn't we have been able to say that 14 was the geometric mean between 7 and 22? That's what we would have been able to say, right? Okay. Well, 14 times 14 is 196. 7 times 22. Do we know what 7 times 22 is? 7 times 20 is 140, right? So is that 154? Is 196 the same thing as 154? No. So that tells me right there that angle up there, not a right angle. Okay. But the overall principle here, and that question is always an issue for students because we've been beaten in our heads in 7.5 and 7.4 this relationship about drawing that altitude on the inside and became the geometric mean. But the one condition was that had to be a right angle up there. And in this picture, we don't know whether it is or not, so we assume that it's not. Does that make sense? Anything else? 21. So this is going to bring us back to, this is a concept we learned a long time ago. And this is the thing about geometry, okay? And my trig students are even recognizing this now. Every once in a while, we'll come across something. I'll say, right now we have to use a relationship that we learned in geometry, like maybe the second or third week of geometry, okay? So it's not real at the forefront of our minds right now. But if I look at this overall black triangle. What kind of triangle is it? It's isosceles, because that's 17 and that's 17, right? And the concept about isosceles triangles that has been a while since we talked about in chapter 4 was that if you take a segment from the vertex angle and it becomes perpendicular to the base, there's three things that are happening here. It's perpendicular to the base, and because of that, we know it should bisect that angle up there. Okay? But for this problem, makes this problem doable, is that it also bisects the 30 down here. It bisects the base. So that distance and that distance are the same. So what does that produce for me? It produces two right triangles. That one has a 17 length hypotenuse. This is x. And now what would this distance right here be? 15. So we have to use that. There was a corollary back in chapter 4 that said, in an isosceles triangle, if you have an angle bisector, then it is perpendicular to the base at the base's midpoint. And then we had different versions of that that allowed it to say, okay, well, if we don't know it to be the perpendicular bisector, but it is perpendicular, then we know that it is then a perpendicular bisector and it is a segment bisector. So those three conditions are always met when one of them is met. Okay, so we got the idea that this is an isosceles triangle, and the condition being met that it's perpendicular there. So the two conditions of congruency with those two angles and the congruency of those two segments there is met then. So now with this triangle, can I say 15 squared plus x squared equals 17 squared? 15 squared, 225. 17 squared, 289. X squared then is, subtract those, what do I get? 64. So what's x got to be? X is 8. What kind of group of numbers do we call that? If they're all integers. That's a Pythagorean triple. That's what, in a student's perspective, that's a question that most people don't like because it's pulling on previous information. That there's a big gap between the last time we talked about it and using it. As a teacher, and just as a math person in general, I love those types of questions because they make you have the understanding or provide the perception that once you learn something in a math course, you can't forget it, which is a terrible assumption, right? And we're going to forget things. If we do forget it, though, hopefully we don't forget the skill or the ability to go to recognize, I vaguely remember this, don't remember it in great detail. Let's go back and research and relearn it real quick so I can use it here. Anything else? What if I gave you a square? So this is going to be section 8.2. I don't know how much of the notes that I've written we'll use, though, today. 3, 4, So we have this square, and you think about our geometry. A lot of our geometry is based from work from individuals from Greece. Okay, a lot of our work comes from Greek mathematicians. Okay, Euclid was Greek, Pythagoras was Greek. Okay, one of the things that they had issues with algebraically, okay, they could do it, they could measure these things with their devices, but they had no way of algebraically being able to determine the distance from there to there. Okay? They had absolutely no way of doing it. Okay? They could take their tape measures or whatever they use, whatever their measurement tools were to measure that distance. They could do that and get an estimate, but they could never exactly find that distance algebraically because the Greeks at that time didn't have irrational numbers. Okay? And I think we've talked about this in the past where, you know, our number line kind of evolved from necessity. Initially, if I'm a farmer or somebody that's at the market and I'm using numbers, I'm probably using numbers like the natural numbers. Okay, I have 1 loaf of bread, 2 loaves of bread, 3 loaves of bread, right? Okay. Eventually, maybe it becomes the necessity for me to have fractions. So I have half a loaf of bread. So we invent or we discover fractions. Say, okay, if I take a whole loaf, cut it in half, what do I call that? Okay, 1/2. I got a fraction. Maybe I cut my loaf of bread into 3 equal sections. And now I have 1/3 and 2/3 and 3/3 and that kind of stuff. So those numbers come to fruition. Maybe I'm a baker and I sold everything, and now I think, well, what do I have? I have nothing. Well, let's attach a number. The number 0 expresses nothing. We talk about the Romans and Roman numerals. There is no Roman numeral for the number 0. Okay. Then eventually we get to the point where, okay, well, maybe I'm a baker and I've sold everything, but I want to go trade for something. Maybe I go find some eggs so I can trade and make more bread for tomorrow. But I don't have any bread right now to trade, so now to that person that I've traded for eggs, I'm maybe trading 2 loaves of bread that I don't have, so now I'm negative 2 loaves of bread. Does that kind of make sense? Okay, so we introduce or we incorporate negative numbers. The Greeks did not have irrational numbers. They did not have numbers like radical 2. Okay, so they were at an impasse for being able to find this distance algebraically. Okay, and then they struggle with this all the time. And this wasn't until, like, obviously Pythagoras was Greek, and then once his stuff was starting to get published, they did have these values. But we got a right angle right here. Okay, this is a square. Okay, so what do we know about squares? What other kind of shape or classification can we call a square? It is a rectangle. It is a rhombus. Let's stop there. I think that if we stop, it's also a parallelogram, right? Because rectangles and squares and rhombuses are all subgroups of parallelograms. But you said it's a rhombus, right, Jagger? Do you remember what a diagonal of a rhombus does to the opposite angles? Makes them equal. Okay? So it's diagonal bisect, and a rhombus, and a square is a rhombus, a diagonal bisects the angle. So if it's a square, we know that's 90, so when it bisects, don't we know that'd be 45? And that also be 45? Okay. I'm just going to I don't like to use S because my S is like 5 sometimes. I'm going to use this as N and N. Those would be the lengths of that side of my square. Okay. Might be, N could be 1, could be 2, could be 3, could be 4, could be a half, could be whatever. Doesn't matter. Okay. Just a random value, but in order to keep the squareness, they both have to be the same. Okay. What kind of, so in regards to it being 45, 45, 90, okay, we also have the idea, and a lot of things that kind of mesh from other areas of the course. If that angle is the same as that angle, Haven't we talked about the sides opposite having to be the same? You guys remember the converse of the isosceles triangle theorem? Okay, so that's another reason why those both have to be in. Okay, because these base angles are the same. Okay, but it's a right triangle, right? So I should be able to find this diagonal using that and that, correct? Okay, I'm just going to call this distance, let's call this x right now. Let's solve for x. Let's see if we can get x to be solved for. And we're gonna solve for x in terms of n. And what that means is when we're done, x will be alone. On the other side of the equal sign, the only variable you will see will be n. Okay? So, what kind of triangle do we have here? It's a right triangle. Okay? Now, I'm going to classify it as a right isosceles triangle, or we can call it a 45, 45, 90. You'll see both terminologies used. Okay? But if it's a right triangle, what theorem that we talked about 2 days ago should be true for it? If it's a right triangle, shouldn't this be true? Okay, what is your A value here? N. What's your B value? N. What's your C value? Okay. How many n squareds would you have here? Correct? 2n squared equals x squared. And now I said I want to solve for x. I want you to be able to tell me what x is, what this length is. So what would I do right here to solve for x? How do I get that power 2 to dissolve, to go away? I'm going to take square root, right? Take square root there. Take square root there. Okay? Now, with our rules of square roots, this is a product. Okay? So product underneath my radical. So what that means is that we can rewrite it as a product of radicals that way. Okay? Now I take square root of x squared. Those are inverses. It just leaves me with x. Now the reason I would do this is, what is n squared? The square root of n squared. What does that change to? It just changes to n. So I get radical 2 times n equals x. Now, there's just a common practice with notation here. If you have a variable with a radical coefficient, so radical 2 is my coefficient for n. Does that make sense? Okay, radical 2 is about 1.4. If I would leave that as radical 2n, just because of typesets and especially writing things by hand, some people get confused. Should the n be underneath the radical or should it be outside the radical? So when you have radical coefficients, what you do, it's contrary to what we've normally done. If I have a coefficient, my coefficient always comes first, right? If it's a radical coefficient, the coefficient comes second. You put the variable first, because now when I write it as n radical 2, there's no confusion on whether the n should be underneath the radical or not. It's to the left of it, so it's obviously outside the radical. Does that make sense? If I do something like this, if I had like x equals radical 2 times n, a lot of times I'll get sloppy with my handwriting, and my radical will like stop right above the n, and I don't know, okay, should the n be over here underneath or should it be outside? Because it's two different meanings depending on where it's at. If you're a person who likes to put the radical first, like I did here, just put a little, I put a little hang down thing. You don't see that in text or anything like that, but it just establishes a location that says anything to the left of that hang down should be underneath, and anything to the right should not be underneath. Okay? But what this says now is that this distance is n radical 2. So, give me a number for n. 4. So if n is 4, what would the hypotenuse here be? 4 radical 2. you now have the length of the hypotenuse instantaneously without having to go through the Pythagorean theorem. Okay? Does that make sense? Okay? And we should be able to check that. I mean, you can go through the Pythagorean theorem. If you go 4 squared plus 4 squared, that equals x squared. And that would be 16 plus 16 equals x squared. Well, that'll be 2. I'm just going to try to keep the algebra as clean as possible here. So 16 plus 16, is that the same thing as 16 times 2? And if I square root then, square root of 16, square root of 2, what's square root of 16? 4. And then radical 2 doesn't simplify, so it's 4 radical 2. Well, I can go through all that, but if I give you 25 questions, do you want to do that on every one of those questions? But if my next question is, I tell you n is 7, would you much rather prefer going up here and say, okay, well, this side then is 7 radical 2? Is that pretty easy? Okay. So the diagonal of a square is always the length of the square times radical 2. Okay. Now, Jagger, how many feet to first base? Joel? 90. Okay. So if I'm on home plate, first base, second base, third base, and I asked you a question in regards to maybe a third baseman standing on the bag. What is his shortest distance that he can throw the ball to? Second base or first base? If my third baseman's right here on the bag, how far will he have to throw the ball to get to second base? 90 feet, right? How far does he have to throw it to first base? 90 radical 2 feet. Okay? Which is about 1.4. Radical 2 is about 1.4, so it's about 90 times 1.4. It's about 135 feet-ish. We can actually have interest in it. Critical values. Let's see here. We can go square root of 2 times 90, 127. Okay, that'd be how many feet you have to throw. Does that make sense? Okay. So what I want to do here, this is called a 45, 45, 90 template. I'm going to show you a structure for going through problems like this because they're not always going to give you n. Okay, they might give you, let's go through and do something like this. They'll say, okay, so it's a 45, 45, 90. What's the hypotenuse here going to be? 2.5 times radical 2. Pretty easy, right? Okay, let's go down to this example here. Are they giving me n here? No, but yes. Indirectly, right? Because this is the n radical 2 side. So the n is the 6.5. Does that make sense, everybody? Okay. Now, what I like to do is use a congruency concept, and this will make sense on the next questions. So they give me this problem here where this is 6.5 radical 2. I take the approach that I have this, I'm going to call it a template. You guys know what a template is, right? Okay. I have this template, and I'm drawing my template so that it is identical to the problem question that they give me, the problem picture that they give me. So if this was 6.5 radical 2, okay, that's a 45, 45, 90. Okay, 45, 45, 90. But now in my template, this is n radical 2. Okay, when I take my template, because I made it congruent, when I do this, what things overlap? The whole thing. So the angles all overlap, right? But doesn't the hypotenuse, which was n radical 2, in the hypotenuse that was 6.5 radical 2, don't they overlap? And if I made the template identical to the original problem that I had, that means they were congruent. That means these distances have to be equal, right? How can I solve this for n right here? A lot of people will say this is a one-to-one relationship, meaning that if, like, you've seen this with fractions, if x over 3 is equal to 2/3, what would you say x had to be for this to be true? You'd say it had to be 2, right? So that's a one-to-one relationship that we've seen with fractions. Same thing happens down here. Yeah, essentially, because to make the left-hand side exactly the same as the right-hand side, that thing right there needs to be that thing right there, right? Okay? But if I view this, think about this. Radical 2 is just a number. Radical 2 is that number right there, 1.414. So I really have 1.4 times n here, right? So if you viewed this as 1.414 n equals 6.5 radical 2, what would you divide both sides by to solve for n here? 1.414, right? That's the scalar multiplier or the coefficient here of n. Okay. Well, what do we say 1.414 really was? Radical 2. So if you would have divided by 1.414 here, then you should have divided it by 1.414 here as well, right? Those will cancel, leaving you just n. Over here, do they cancel again? You leaving you just 6.5? Okay. Now, a lot of you say, that was too much. I'm not going to do that. That's stupid. That's a waste of my time. And I agree with you on that question. Because it's easy to see that the hypotenuse is identified as n radical 2, and they give me the hypotenuse as 6.5 radical 2, then n has to be 6.5. Okay? Much like this bottom one here. What does n have to be here? N has to be 5. Okay? What does n have to be here? N has to be r. What does n have to be here? 2/3. Good. We can do that, right? What does n have to be here? You're not seeing, I hope there was well, crap, I don't know what to do. Okay? Because there is no longer a radical 2 there, right? The radical 2 has already been multiplied and processed inside this 15. It's already in that product. Does that make sense? Okay? So what do? We say, okay, I'm going to create a template that's exactly the same size as that thing. And this is n. This is n. This is n radical 2. And if I take my template and I put it right on top there, what two things overlap? N radical 2 and 15, right? When I say two things, I'm talking about what two distances. Okay, so n radical 2 and 15 overlap. So I'm going to say n radical 2 equals 15. Because I created my template creatively so that it was congruent to that red triangle, right? Does that make sense? Or orange triangle. So now how do I solve for n there? Divide by both sides by radical 2 and radical 2. So now I get n equals 15 divided by radical 2. And this should make sense, okay? If I gave you a side length, what do you multiply it by to get the hypotenuse? Radical 2, right? Okay. So going from a side length to the hypotenuse, an unknown hypotenuse, you multiply it by radical 2. Well, if I give you the hypotenuse and I ask you for the side length, now we're going in the reverse or inverse order, right? So if you multiplied to go from leg to hypotenuse, doesn't it make sense you should divide to go from hypotenuse to leg? Does that make sense to everybody? Okay. So I'm going to divide by radical 2 in that situation. Okay. And that's always going to be the case. But I'm a person, and especially as we go through the rest of the year, every time we see a special right triangle like this, I'm going to go through this formula here with you. Okay. So n equals 15 over radical 2. Now, do I like radical 2 in the bottom here? You guys remember that? We talked about rationalizing denominators. We don't like irrational numbers down here. Okay, so what we're going to do is we're going to grab that radical and multiply the top and the bottom by it. Good. 15 radical 2 on top and 2 on the bottom. Now, 15 and 2, the numerator and denominator, so the numerator is 15 times radical 2. Okay? So 15, let's write it this way, 15 times 1.414, and that thing keeps going on forever, over 2. Are there any common factors between the 15 and the 2? It's the common factors. So you came up with you multiplied them and got a LCM. But is there anything that divides the 2 evenly and the 15 evenly? No, so there's no cancellation there, right? Now, here's one thing to think about. That 1.414, which is radical 2, that's an irrational number. Okay? So you can never take, a fully simplified irrational number will never have rational number factors. So 1.414, to get that product, if that's the number I'm looking at, then its product will not be done by using rational values. Does that make sense? So what I'm saying is that there's no common factor between 1.414 or radical 2 and the whole number or integer 2. Does that make sense? So what I'm getting at here is that there's no simplification here. You're not going to do anything more than leave that alone. Okay? Where if I get to this 12, this one here, this question with 12, okay? So again, I'm going to draw my template. Let me just erase this. I'll draw my template. And the two distances that overlap are n radical 2 and 12. So there's my equation. N radical 2 equals 12. How do I solve for n? Here's me n equals 12 over radical 2. A lot of you are probably going to find patterns with this eventually. But I'm always going to multiply then by this radical 2 down here. It gives me 12 radical 2 over 2. Okay? Which that is 12 times 1.414, so on, right? Which isn't that 12 the same thing as 2 times 3? Does that make sense? Times the 1.414 on forever, all over 2. Will those cancel? Does that make sense? And what are you left with? 2 times 3, 6, and then times this 1.414 number, which was radical 2, correct? So 6 radical 2 is the answer. And the reason I'm doing this stuff down here, okay, is to demonstrate that even though when I look at the 12 radical 2 and the 2 on the bottom, if I disregard this radical symbol, they all share a common factor of 2, right? But that radical is a symbol for a different number. I want to make sure that people don't do this, because it happens every year. 12 radical 2 over 2, that they don't go, oh, yep, that's a 6. Oh, that's a 1. 6 radical 1, which is just 6, right? You cannot cancel that number there with that number there. Okay, I always view this as being locked underneath the radical. It's kind of like a cage. Okay, can't do anything with it until that cage is gone. All right. So that's something we can do. What about do one more here? What's this one? This one's a little bit more difficult. If I take my template, does everybody see that the n radical 2 would land on top of the 12 radical 3 over 2, right? So there's my equation. N radical 2 So every time that you guys come to me with an individual question, I'll ask you, what's your equation? What two things are relating so that you know whether you either divide by radical 2 or you multiply by radical 2? Okay? What would I do here to solve for n? Does this matter at all? Do I even care what that thing is right now? What was the step when it was 12? What was the step when it was 15? I divide by radical 2, right? I got to isolate the n. So I'm going to come over here and divide by radical 2. Okay? And I cannot leave my answer like this. This is a nasty, you know what this is called when we have a fraction inside a fraction? Compound fraction, good. Okay? Compound fractions, not good for us to leave as a final answer. So would you guys agree this radical 2 has a denominator of 1? You guys remember how to divide compound fractions? Anybody remember how to divide by a fraction? Dividing by a fraction is hard, isn't it? If I ask you to take 5 and divide it by a half, that's hard to do. And we never really do it. Because we take the 5 and multiply it by the multiplicative inverse of 2. Does that make sense? So when you divide a fraction by a fraction, you never really physically divide. You're going to use the relationship that products or multiplication, division are inverses. So I'm going to take that, and I'll find its multiplicative inverse. It's reciprocal, which is 1 over radical 2. Does that make sense? So I'll go straight across the top, I get 12 radical 3. Straight across the bottom, I get 2 radical 2. Okay. I'm a person, I want to simplify last. So I know that this radical 2 is down here, right? I don't like that, so I'm going to multiply by radical 2. My ink pens have been all messed up. Multiply by radical 2. Radical 2. Does anybody remember how to multiply radicals? Which numbers? Okay, so that's going to give me 6. So the numbers that are on the inside of the radical, I multiply the radicands and they stay as a product underneath. So that's my new radicand. What do I do with the numbers outside? What do I do with that 12? Good. Good. So I multiply that 12 by the 1 that's out here, the understood 1, and I get 12 out front. On the bottom here, same idea. Okay, I get 2 times 1, which is 2. And now I get 2 times 2, which is radical 4, right? What's radical 4 turn into? Which turns into 2, right? So this here is really 2 times 2, which overall is 4. Now what can I do there? Simplify the 12 and the 4. It gives me 3 radical 6. So now let's see something. Does this make sense? Let's take, because this is going to be a right, so this is how you check yourself if you want to make sure this is all right. If this is a 45, 45, 90 triangle, we just said that that's 3 radical 6. We just said that that's 3 radical 6, right? What theorem should be held true here? If it's a right triangle, shouldn't 3 radical 6 squared plus 3 radical 6 squared equal 12 radical 3 over 2 squared? Now this is an algebra kind of activity here and understanding our laws of exponents. What's 3 squared? 9, right? So 3 squared will give me 9. What's radical 6 squared? 6. So what's 9 times 6? 54. So that's 54. And that's 54. Okay, now over here, what's 12 squared? 144. What's radical 3 squared? 3. What's 2 squared? 4. Anybody know what 144 divided by 4 is? Say again? Not 144 divided by 4. Not 6. What's 144 divided by 2? 72. What's 72 divided by 2 then? 36. So that goes to 36. I got 36 times 3. What's 36 times 3? 108. What's 54 plus 54? 108. So because I get that Pythagorean theorem to check, that tells me I got the right 3 radical 6s for those values there for those sides. Lots of algebra there, right? Okay, I had a lot of kids today coming to me asking me to sign their sheet to get into calculus, which I've told every one of them, you are smart enough, I will sign it. You're going to calculus. But no, that calculus isn't hard. Okay? All our math classes, all our individual math classes, like physics, which is a science class, but it's heavy in math, physics, trig, college algebra, calculus, and statistics, those things the concepts aren't hard. Okay? It's the algebra that we use inside those concepts to provide us with information that people struggle with. Okay? It's laws of exponents. It's knowing how do I divide a fraction by a fraction. And those are things that pop up in one question, and then you not see it again until 15, 16, 17 questions later, or maybe even 15, 16, 17 assignments later. Okay? But the algebra is, if you struggle in math, in all your class, whatever it be, geometry, stats, calculus, college algebra, trig, whatever it may be, it's not, I would guarantee you, I would say 99% confident, it's not because you're not intelligent enough to understand the concepts. It's because your algebra skills aren't strong enough to be able to work within those concepts. Okay? So at any time you guys are struggling with this stuff, I'm going to ask you, okay, what do